You're given an array of bits denoting the state of n lights. 0 means the light is not working and 1 means the light is functional. If you have a budget to repair exactly k lights, what is the length of the longest continuous sequence of functional lights that you can make? And what lights you need to repair in order to create the longest continuous sequence? Okay, in other words, you need to flip optimally exactly k bits from 0 to 1 to get the longest continuous subsequence of 1s. In our case, with k equals to 2, we can flip these bits in order to get a subsequence of length 7. On the output, you need to print the length in one line and then the indices of the bits that you flipped in ascending order like shown. The indices are 1 based. If there are multiple optimal solutions, you can print any of them. The constraints are quite tight on this problem, so you have to come up with a fast enough solution. You can pause the video now to solve it yourself and come back. Okay, the key observation is that it's always optimal to flip consecutive zeros. But of course, there could be ones in between. We don't care. We can easily give a contra example if you flip 2 zeros and you leave a 0 in between. Then one of the flipped zeros won't be in the longest continuous subsequence. So the problem boils down to a two-pointer technique which allows you to track the two boundaries of the longest continuous subsequence and create it in O of n time. First, you can always flip the first k zeros. Flip them and move the right pointer to the end of the subsequence. We're going to mark the flipped zeros with a yellow color, so we know actually that we need to flip them back. In the implementation, however, I don't flip anything, but you'll see the implementation at the end of the video. After we have flipped the first k zeros, we can track the best solution by marking two pointers, best left and best right. This is how we're going to recreate the solution at the end. After doing this, it's only a matter of shifting the pointers by 1 0 to the right and seeing if the new range we create is bigger than the previous. However, there are multiple edge cases which you need to be aware. So not to go into unnecessary details, you can watch me struggle to code this for the first time live and do live commentary as well. In the implementation I explain some more details, but I would encourage you to try the problem yourself. It's kind of fun. Here is the original transcript in Macedonian. So yeah, okay, let's, so I don't have the test cases here. Let's just copy and paste all the test cases. Okay, so I have all the test cases. Okay, really quickly, so n and k, we are getting n and k. N is the length, so we want a vector of bool, let's call it lights, which has n. We are going to go through all of the, read all of the booleans. Okay, and first of all we are going to need some variables. So int left, I will say it's 0, int right, the right pointer I will say is 0. So this is the double pointer, the pointer 1, the pointer 2, left and right, whatever. Best left will be 0 and best right will be 0. So we have the best left and the best right. So in the best optimal case, so where we put in the best optimal longest subsequence, we're going to remember just the best left and the best right pointer, so we can reconstruct the sequence again. Okay, so while so we need to flip, so while okay, I will have another variable, so flip zeros. So we need to flip the first k zeros. Okay, so there could be ones in between, but we don't care. So while flip zeros is bigger than 0, right? If lights of so of the right pointer, we are going to if the right is not, if it's not on, we are going to repair it. We are going to flip it to 1. By that, I'm not going to flip it. I'm just going to move the right pointer by 1. Okay, and this way I'm going. No, I'm going to negate the flip zeros and always move the right pointer, because you can move the right pointer even there if there is 1 on this. So you move the right pointer. So okay, and then I'm going to say, so best left is going to be 0, best right is going to be right. So I'm not sure if like here is -1. I'm not sure about that. I'll see. So while right is smaller than n, and for the sake of this, I'm going to say even and the left is smaller than n. This is not gonna happen, actually. Okay, so we need to do the following. We need to say that we need to do the following. So while lights of left, so lights of left doesn't actually mean that there is a lights of left, but wait, would this work? So now I need to move the left pointer. If it's 0, if it's 0, I need to move the left pointer. Okay. If it's 0, if it's 1, I need else I need to move the left pointer as much as possible. Okay, else lights off. If it's 1, I will move the left pointer until there is a 0. So okay, until I find a 0. When I find a 0 on the left pointer, it means this 0 needs to be turned off. So we need to, this 0 needs to be turned off. So I need just to do left plus plus. Okay. Okay. Now something similar for the right pointer. So the right pointer is going to be at 1 always. So I'm going to move the right pointer to the next position, right? Because I can now push on the next position. But moving it here, I need also so right plus 1 is smaller than n, and left and lights at right plus 1 is on. So if there is an adjacent one, so I need to extend it, okay? And now I need to extend it as long as there are adjacent ones. So now we need to update best. So the way we update the best positions of those 2 pointers is we say best right minus best left. So the difference of those is smaller than the So if that difference is smaller than the right minus left pointer, we say best right is the right pointer and best left is the left pointer. Okay. So if I think that should work, but I may be wrong somewhere. Best right minus best left plus 1. So we see how this is the difference, okay? And then we go from the best left to the best right. And then we ask if lights of I is turned off, we need to say that we are going to turn it on. So I plus 1. It's not in the line actually, it's here in the line. Okay, so I'm expecting something wrong here. Okay, 3, 1, 1. Wait, what? Doesn't make sense. Oh, flip zeros should be K by default here. Okay. Okay, now this is way too much. Okay, let's see where what is this? So here I think right minus 1. Not sure. Okay, now let's test out on one more. I mean, like, let's test out on this case. So this should be like this. Yeah, okay, it's failed. Because why is it failed? Because I don't have here while. Okay, so if like I see this is 1, so while right plus 1 is smaller than n and light at right plus 1, so while I can extend this pointer here, I will extend it. Right plus plus. So this should work as well. So Mitko from the future had this smaller right here. I need to decrease right minus minus. So this took me, I don't know, 2 minutes to debug. So I want just to skip it, but I didn't mention it afterwards. So right minus minus you need to decrease because always the right pointer is always on the last one possible, not on the last 0 after the last one possible. So it's yeah, but with this passes all the test cases. Okay, it passed all of the test cases. Okay, so yeah, that's pretty much it for the solution of this problem. If you, of course, someone's gonna come here and gonna have a even better solution. But yeah, this is the core of the solution, double pointer technique. Okay, thank you guys so much for watching. I'll see you in the next video.